Hello, welcome to IBCC channel. In this video, we will talk about how to group the BGP neighbor. In other words, how to configure BGP peer group. All this configure is based on the Cisco IOS and just with the IPv4 address family. So how to do it? So when you in the Cisco IOS router, you do the conf-t. Then you type the router BGP followed by the ASN. Under the router BGP context, your first command you issue neighbor peer group, then give the peer group name, whatever name you want it is. And the next command is a neighbor, the peer group name you just created. Then remote AS, put the remote AS number here. Then third command is neighbor, and name of the group. This name of the group you just create. Then do the update source, the source interface. This is an optional command. Then the next command means which peer you want to put into the peer group. The command is neighbor and IP address of the peer. The keyword peer group followed by the name of the peer group which you just created. Then you can use another command to override the remote AS. This command is for this neighbor IP address. So you use a neighbor peer IP address remote AS, and then followed by the remote AS number. This command can override the second line command here, right? Second line because you use you specify the remote AS based on the peer group name, so you can use the remote AS in the neighbor IP command to override the neighbor in the peer group command. So take a look at this diagram here and illustrate the configuration. So R1 have two iBGP neighbor, R2 and R3. Also have the two eBGP neighbor, R4 and R5. For R1, that is a perfect place to group these two BGP neighbors into a group to make a configuration simple, and also group the eBGP neighbors into another group. So here is the configuration. In the R1, you go to the router BGP, AS number is 100. First, you create the neighbor peer group. Use the command neighbor peer group. Give the name here. I give the name called the internal. So this peer group name is internal. Then use the neighbor internal remote AS 100. So since this AS is 100, so 100 here. Then we do the neighbor internal update source. I want to use update source, the loopback 1, loopback 0. So I use this command here. The next, I want to put the R1 into this peer group. So I use the R1 loopback interface. So I use neighbor 2.2.2.2 peer group internal. Also, I put the R3 loopback interface into this peer group. Command is neighbor 3.3.3 peer group internal. Okay, that's it. This is I create the internal peer group for all the iBGP and put each iBGP neighbors into this peer group. This is this make the configuration easy, and in the future, if you want to apply the BGP policy into this neighbor, you can directly apply the BGP policy towards to the peer group internal. So the below is also create another peer group called external. So command is neighbor peer group external. Then I put this external neighbor 40.0.0.2. This one is R4's IP address into the peer group external. there is a R5. I also put the R5 into this peer group. So R5 IP address is neighbor 70.0.0.6 here, peer group external. Since the external router have its own AS number, so the next command will specify the AS number for each individual peers. So use neighbor 64.0.0.2 remote AS200 for the R4, since R4 is AS200. And next command is neighbor 70.0.0.6 remote AS300. So since R5 AS number is 300, this command is specify the AS remote AS for the R5. So this is a basic configuration for how to group the BGP neighbors. Okay, let's go next. So next we will talk about the how to originate a BGP route. So that means how to let BGP advertise a route. So actually, we talk about how to let the BGP router originate the routes, right? What means originate routes? That means that this BGP routes is originate from this router. It's not advertise other BGP routes. It's a routes which originate directly from this router. So the command is this. So you under the conf T, you go to the router BGP followed by his own ASN numbers. Then you use a network command followed by the subnet. Then for keyword mask, then followed by the exactly mask for the subnet. So this command is based on the Cisco LS. Different platform have a different way to originate the BGP routes, right? So here are some notes here. The network command is used by the Cisco router to originate a BGP route. It requires an exact IGP routes existing in this router's routing table. So that's if there is no exact IBGP route existing in this router's routing table, the network command will not work. This means to originate a BGP route from the router must have exactly IGP routes existing in his RIP. So one way to create an exact routes in the RIP is to use the static routes with the next hop non-zero. So the command like this, right? So you can, for instance, if you want to originate a network, use network command 64.72.0.0, and mask is 255.255.255.0. IP route, you use IP route 64.672.0.0, 255.255.255.0 now. This static route is exactly match this BGP origin route. Since this static routes you create, then you create the exactly IGP routes in this router's the routing table. So then BGP can use a network command to originate these commands. Okay, this is all for this videos. Okay, thank you for watching. If you like this video, please give some up.